So today we'll discuss about the data structure. Smriti, is it visible to you? Manoj?
Yes, ma'am.
Yeah, okay.
Yes, ma'am.
Yes. So we'll start with data structure. So there are two words. First one is data and another one is structure. So what is data? Data is any raw information. It's defined as raw facts and figures represents the data. And structure is what? Any arrangement, systematic arrangement. So what can we conclude from this word data structure? It is systematic arrangement of data, or it is organized data. So we'll see how the data is organized. Yes. So there are different ways of organizing data, and in class 11 we already learned one of the data structure, that is list. So what is list? List is a ordered collection of items. So what do you mean by ordered? It means whenever you are storing data in the list, it is stored in the sequence. For example, say consider this list. So what are the values which are stored in this list? The values are 80, 60, 70, 85 and 75. So these are the elements or the values which are stored in the list. But now what is the index of those values? So it will start with yes. So index starts with the 0. So first element has index at 0 and the index will be incremented by 1. It means for the second element index will be 1. So the indexes are 0, 1, 2, 3, 4 and so on. So these represent the index. But now there are two types of index. First one is positive and another one is negative. So what is negative index? It will start from the end of the list and it will start with -1, and it's like this: -1, -2, -3, -4 and so on. So this is what list values and the indexes of the list. Yes, and whenever you want to store elements in the list, they are enclosed in the square brackets. So remember like this. Consider this example of list 1 and the elements are stored like this: English, Hindi, 1997 and 2000. So these are the values or the elements that you want to store in the list, and they are enclosed in the square brackets. So this is how you will create the list. So lists are enclosed in square brackets and each item is separated by comma. So this is how you will create the list. Yes, so whenever you want to iterate through a list, how will you access the list? You will access the list using loops. So one of the loop is for loop and range function is used. So for I in the range from 0 to length of the list, you are going to print list of I. So I is what? I is the index of the list. Now consider this example. List is having 3 elements, that is 3, 5 and 9. So what is the length of the list? Length of list, that is len, and you are passing the name of the list, that is list, to this function. So it will calculate the size. So what is the size of this list? 3, 5 and 9. Yes. So there are 3 elements in the list, 3, 5 and 9. So the size of the list is 3 and it is starting from 0 and till 3. But what is the thing that you need to remember for range function is that the last index is excluded. What do you mean by excluded? It is not considered. So it will start with 0 and it will end at 2. So what are the things? 0 is what? First index 0, 1 and then 2. So all 3 elements of the list are printed here in the output section. So this is how you will iterate through a list. Yes. The another data structure is stack. So stack is a linear data structure in which all the insertion and deletion of the data values are done at one end only. For example, consider that you have books. How will you manage those books? You will keep one book over other, the next is on other, and so on. You will create the stack of the books. So this is what stack. But now consider a case that I want to take one book out of that stack or out of that bundle. Which one will be picked first? The one which is kept on the top, that will be removed first. So this is how the one which is inserted at the last, it is removed first, and this is known as last in first out. So focus on this term, that is LIFO. It stands for last in first out, and this property is related to which type of data structure? It is related to stack. So you will be asked what is LIFO. So you need to explain it like this. And this is a diagram which demonstrates the stack. And the operation to insert values in the stack is known as push operation. And the operation which is used to remove elements from the stack is known as pop operation. So remember these two operations. Whenever you are adding elements to the stack, it is push, and whenever you are removing elements from the stack, that is pop operation. So this is about the stack. And LIFO is what? The last element which is added, it is removed first. So this is stack. Yes. Now we'll see what are the applications of stack. So first one is string reversal. So what is string reversal? Consider that I am adding, say, string as computer in the stack. So how will it be added actually? First thing which is added will be C. After that I will add O. As stack is what? One element is over another. So I am writing that like this: COMPUT. Then here it will be E and then R. So this is what? Computer. Yeah, correct. So this is, consider this as the stack. Now how will I remove the elements? I will remove first which element? R. Say I removed it from here and I place it here. Then I will remove E. I will place that E here. Then I removed T. I placed that T here. And so on. I am removing one element and keeping it here. So now M is removed and it is placed here. Now it's O's turn. Again it is removed and O is placed here. Okay. So again I am removing C and I am keeping that C here. So what is the thing that I am getting? I am getting the reverse string, that is add, that is RETUPMOC. So are you getting how is it happened? So whenever you are popping each element, you will get the string in reverse order. See, in this case what did I do? I keep that string in another stack. That's why you may see that it's as a original string, but it's not. For example, consider the short example. Say ABC, represent the string so that you won't be confused. ABC, this is one string and it is kept in stack like this: A, B, C. So this is the stack. So instead of, after popping that element, instead of keeping it in stack, I am keeping it here. That is in a list only. So first will be C. Say I removed that C. I kept that C here. Then I removed B. I kept it here. I removed A and I kept it here. Yeah. So it's now clearly visible that ABC is reversed as CBA. So instead of keeping those elements in the stack, now I kept them in a list, in a sequence as a string. So this is what? This is the application of stack, that you can reverse any string. So this is the first application. Now we'll see what is the next one. Next one is function call. So what is function call? Stack is used to keep information about the active functions and subroutines. So remember one thing, whenever you are calling function, the flow of execution of program is shifted from this particular block to the function definition, and after executing all the instructions in function definition, the pointer again comes to the next instruction in the main block. So where should that pointer return? That is maintained using system stack, and this is the application of the stack. So remember that if you are asked write down the applications of stack, you will mention two applications. First one is the string reversal and the next one is a function call. So this is the about applications. Okay. There is one more application, I will explain it here. For example, consider that which is known as parenthesis matching. For example, this is A and I am saying say A plus B, and this is what is into 2, and consider that there is one more bracket, say this and this one. So whenever you are, say I keep this bracket here, I am traversing this function and I am keeping this bracket. See, the first one is this one, so I kept this bracket here. The next one is this, so I kept it here. Now I will go on scanning the expression A plus B, then again closing brackets. So what will I do? I won't store this closing bracket here, but I will pop out this bracket. So this is popped out. It means this bracket is matched. And now I will go again here. So here it is again closing bracket. So again I will pop it out. So this means the brackets are matching, that is parentheses are correct. Consider if it is not here, and again I am storing it here from here. Now as this is, these two are stored. Now I will come here. Yeah, this is the correct one. So I will remove this, and now there is no closing bracket. So this one bracket is remaining. It means the parentheses are not correct. They are incorrect. So this is how it is used to check whether the expression has correct parentheses or not. So that's about the applications of stack. Yes. The next data structure is queue. So consider that you are in the queue of, say, queue at the store to purchase something. So how is it different from stack? So we'll see how is it. For example, say in the queue, the person who is coming first, he will be given, say it's a consider any shop, say newspaper shop. So he will be given the newspaper first. The second one will get it at the second position. So consider that if there is a stack instead of queue. So what will you do? You will go to that place. Means you will delay to go to that place. So what will be the result? The one who is coming late, he will be given, say, that newspaper first. But it's not the queue. So queue is followed exactly in the reverse way as we studied in case of stack. So what is the principle of the queue? It is FIFO. So what is FIFO? It stands for first in, first out. It means the person who is coming first, who is early, that person will be given newspaper first, which is actually opposite of the working of the stack. So this is the principle of the queue. First in, first out. So queue has two ends. In case of stack, it has only one end. For example, see, yeah. So if the elements are inserted from this end, that is using push operation, they are removed from this end only. That is using pop operation. But in case of queue, there are two ends. It means it is inserted from, say, this back, cause the person who is coming late will stand in the back, and the one who comes early, he will be removed first from the front. So remember that it has two ends, which are known as front and back. And queue operation, that is adding new elements in the queue, will be performed at the back end, and dequeue operations, that is removing elements from the queue, will be performed from the front end. So this is what is a queue. So what is the principle of the queue? It is first in, first out. Now we'll see what are the applications of the queue. So it is what? It is used for scheduling. So what do you mean by this? When a resource is shared among multiple consumers, it is scheduled. For example, you have only one printer in computer lab and all the students want to print their practicals. So everyone will say Control P, print, print, print. But how will that printer will manage the thing? So that printer will note down the timing. The person who gives the print command at the earliest, the print of that person will be delivered first. So this is what the scheduling. So that printer will manage one list or one queue, and say Manoj give that command first. After that Smriti, then say Hardik, Priyanka, Priyanshu. So everyone's print command will be here, and the first one who gives that command, his print will be given first. So this is what? This is the scheduling of the resources, and that is managed using queue. So you will be asked what are the applications of the queue, then you can explain it using this concept. And you can draw the diagram like this, showing and queue, dequeue operations, and explain FIFO concept or the principle of the queue, which stands for first in, first out.